Welcome back to the channel. Today we're in my home office, not the usual place for one of my YouTube videos. However, we need to address these office desks. I spend a tremendous amount of time in my home office, both as an engineer, where I work from home, as well as trading stocks, as you can probably tell from what's on the screen behind me here. Now, I recently remodeled this office space and we love it. New flooring, colors, trim, it's awesome. However, these desks have got to go. Both my wife and I have similar desks. They're made of wood, they're old. This desk was actually in the home when we bought it almost 10 years ago, and it's just not functional. It doesn't mount screens like I need it to. It's not stylish, and it's got to go. I do have several requirements for a new design. Obviously, I have a lot of screens. The particular stock trading method that I use requires me to look at several different time frames at the same time, and I need many screens to do that. I have 5 screens currently. We're actually going to be going to 7, so I need to design a good way to mount the screens to the desk. I also have 3 computers running right now. A desktop machine that I use for trading as well as photo and video editing. I have a Surface computer that I use for many work items, as well as this small computer here that I use to run dedicated software for one of my businesses. So I need to get all that organized and tidy and find a good way to mount them into the desk and keep things organized. I will say, when I put the desk in here after the office remodel, I just kind of threw it in here. I didn't do the organization that I typically do with the cordage and getting things organized. I knew it was going to be a temporary installation, but I am dying to get things organized. I really dislike having cords all over the place, and I'm excited to get the new desk built and get all of this installed properly. So that's going to be a big goal. Lighting is another issue. I have been using this overhead LED lamp. It's been okay, but I think there's some better ways of doing it, so we're going to be working on that. As you know from past videos, I like to work in steel and concrete, so that is what we're going to be using. I'm going to try and make it modern and stylish and functional. I'm going to be building a matching desk for my wife. She also spends a lot of time in this office as well. So, with all of that intro, let's go ahead and get right into the design and see what we can create.
All right, well, as with most of my fabrication projects, I like to draft the design to make sure I'm not missing anything. In the past, with a variety of projects, I have found things where visualizing it like this really helps me make sure that I've got sizes right and don't miss any clearance issues, etc. I do use Illustrator for a lot of 2D stuff, but for this type of 3D drawing, I've found that SketchUp works best for me. There are a lot of different ways to go about it. But after messing around with some different sizes, I did determine that 3-inch square tube is going to be best for these desk legs. I originally planned a cross design here in the side panels, but in the end I decided it's just too boring. I want these desks to be unique. And so I went back to the drawing board and came up with this design, which uses sheet steel for the side panels as well as the modesty panel. I've been using laser cutting for a lot of projects over the past couple of years, and really figured that I could make these desks unique and beautiful by having a geometric design laser cut into these panels. And for that, I went through hundreds of stock designs and found this pattern in Adobe stock. We literally looked through hundreds of these type of templates, just looking for the right thing. And this ended up being, I think, a good mix of kind of the design ideas that we had. And so I got this into Illustrator and got it kind of to the dimensions that I needed. This is the modesty panel, and then this is the side panels. Once I got all this kind of straightened out and just to the exact right size that I wanted, I'll be sending this out to my local laser shop. And I'll have these panels cut in 14 gauge steel. Back to SketchUp. The last thing I needed to work out was the keyboard drawer. I was able to buy a keyboard drawer that fits our requirements. I still wasn't sure how I was going to mount it under the desk though. But once the drawer arrived, I could make some measurements, and I realized that I could just cut a slot into this piece of 3-inch square tube, and then mount the drawer to a piece of plate behind. This will be 3/16" steel plate. I'll be able to mount the drawer mechanism to this. I do have a couple of pieces of 1-inch square tube to help support all that. And I think it's going to look cool and be perfectly functional. The drawer is just going to slide right into the side of the desk and be out of the way. I think it's going to be perfect. I'm not a pro machinist, nor do I have pro equipment, but I think I'll be able to cut this slot in the tube without too much trouble. You might say it's going to take a lot of strength away, but this thing is so over-engineered. It's going to be super strong, lots of reinforcement on the back here, so I think it's going to be just fine. For the top, I'm going to build this out of glass fiber reinforced concrete. Over the past 10 years or so, I've made a couple of dozen GFRC concrete pieces for a variety of applications, mostly countertops. I can do almost any color you can imagine, but we've decided that a light gray will work well in our current office space and will be flexible enough for any office space that we have in the future. To mount the screens, the computer screens, I plan to drill a 1/2-inch hole through the concrete and then through the 3-inch steel tube. And I'll do that at 3 different places, one on each side and then one also right in the middle. And these 3 places will all be available for using a bolt through the concrete and steel to secure a tube that will be used for the screen mounts. And for any holes that I'm not using for mounts, I'll install an elevator bolt through, and that'll keep a nice clean look and help secure the concrete top to the steel base. I'll also drill larger holes for cordage to pass through the concrete. And then I plan to mount cord management trays along the inside of this steel tube here. And that'll help keep everything nice and tidy. So now that I've got a final design, I'll place an order for the steel and the laser cutting, and we'll get this project started. All right, well, I just got back from picking up a bunch of 3-inch square steel tube for the desk project. This stuff comes in 24-foot lengths, and it's actually too big to fit in my garage. So I'm going to cut this down to the lengths that I need right here in the driveway. With the steel cut, I can go ahead and start building the desk. I'm going to start with the feet. Here are the parts I'm going to use: 3/8-inch weld nuts, steel plate, and threaded feet. You can see the feet have rubber bottoms, which will help protect the floor and also make the desk adjustable at all 4 corners so I can make sure it's perfectly level and stable. Once the nuts are welded to the plate, I will weld this whole system to the bottom of each leg. One skill that I'll be using a lot of during this build is blending welds. There's a bunch of different ways to do it. The way I like to do it is use a conventional grinding disc to knock down the high parts of the weld, and then use a premium flap disc to blend the weld with the rest of the material around it. For this project, I was using the Preferred Tools Paul-Lively's flap discs. They seem to do a great job of leveling and finishing all in one step. Next, I'm going to assemble the side panels. This is basically putting 4 pieces of square tube together to form a square. I had been looking for any excuse to buy this 3-axis vise, and this project was it. Worked great, although it's not perfect. It definitely helps align the pieces into each corner to make sure I get a nice and a square fitment. Once I had welded the 2 side panels together, it was back to the blending process. That was definitely a theme of this whole project, the blending of welds. Practice makes perfect. Now that the side pieces are welded and blended, we are ready to install the laser cut panels. Now this is the first time that I've had a piece laser cut and the drops have not been removed. The drops are the pieces that should be gone. You can see here they are still present and they're held by a small piece of metal, almost like the laser cutting outfit didn't quite have their laser go far enough to completely cut it. So I had to manually remove each piece, kind of frustrating, although kind of fun to watch here on the time lapse. If you've ever experienced something like this, leave a comment. With the drops removed, I was able to fit them into the welded legs and weld the side panels into place. I used these pieces of 3/4 inch hardwood that I had laying around to evenly space the side panel in the legs. Next was preparation of the cross members. After dressing the cuts and making sure they were the exact same length and also the same length as the laser cut modesty panel, I created a hole for this outlet. I thought it was going to be important to have power, both 120 volt as well as USB power on the front of the desk. In order to make square holes in the steel tube, I use a cutoff disc on a grinder to get the bulk of it done and then use a reciprocating saw to finish off the corners. Next was the slot in the tube for the keyboard drawer. I decided there was going to be a little too much material removed and I needed to add some strength, so I found this piece of 1/4 inch bar in my stock and was able to weld it to the bottom to really give it a lot of rigidity. Here is the cut in the square tube for the keyboard drawer. I did decide to only cut the back side and wait to cut the front side until I actually had it installed in the desk. Once again, just helps keep everything nice and square and rigid. Now I'm working on the opposite cross member, mounting the cable management trays. I'm using 3 trays and I was able to use self-drilling screws, worked great. Here I'm welding the cross members to each of the end panels. This is really an exercise of measure twice or 10 times and weld once. This is a critical step into keeping the desk completely straight and level. The legs have got to be parallel with each other and everything has to be just right for the desk to actually sit flat on the ground. Obviously, a huge welding table would be super beneficial for this part of the project. I can't justify a big welding table for so few projects, so I was able to make do by shimming things just right on the floor. Here I'm installing the mounting system for the keyboard tray. I'm using 1-inch square tube and 3/16-inch plate, and found that this really helps stiffen up the desk. It helps support the slot in the square tube for the keyboard tray and ties everything together very nicely. Now I'm welding the laser cut modesty panel into the desk and adding a piece of 1-inch square tube on the bottom to tie it all together. Here is another round of removing the drops from the laser cut modesty panel. Although this was not a good time, it is actually a lot of fun to watch this on the time lapse. With the desk assembled and fully welded out, I went ahead and cut the front slot for the keyboard tray. I was also able to make a final mounting of the keyboard tray so that I was comfortable that everything would fit during final assembly after powder coat. After I had everything test assembled and finished with the welding and blending, I spent quite a bit of time finishing and cleaning the desk, removing any weld splatter, lots of time sanding to make sure everything is nice and smooth and ready for powder coat. All right, so I'm ready to build the concrete top for the desk at this point. Now the method that I use for concrete countertops or artisan concrete projects is glass fiber reinforced, or GFRC for short. I started doing GFRC projects about 10 years ago as a hobby, really. And at this point I've probably done about 40 pieces over the past 10 years. Now there are a lot of different ways to do GFRC. I'm going to kind of just briefly show you my process. It's a process that I've kind of refined after all these projects, and it works good for me. There's tons of YouTube videos on how to do GFRC. So I'm going to just kind of briefly show you the process that I do. Like I said, there's different ways to do it. But if you do have questions about how I'm doing things or things that I leave out, feel free to drop a comment and I'll respond to you right away. The first thing you'll notice is that I've got my flatbed trailer. This is a twin axle 18-foot flatbed, and it's hard to find something flat. A concrete floor is not flat, you'll find. If you take a laser or a straight edge and do some measuring, you'll find that almost every concrete floor you find is not flat. And so it's very important to have a very flat surface to do this. And after a lot of searching and trial and error, I found that the flattest thing I had is my trailer. When it's on level concrete, both axles are level, the tongue is level, and everything is nice and level. This thing is laser flat. It's also nice because after I do the concrete pieces, I have to take them outside to grind and hone. I might do that several times depending on the piece, and it's just easy to move it in and out when it's on the trailer. So it's a little goofy, but I can't justify building a huge steel table when I just do so few projects with this method. So we're on the trailer. I do have plastic out. I spray the first coat of cement into the form, and so we'll go over that a little bit later. But the first thing, of course, is building the form for the top. Now I do a lot of countertops, and what I would typically do is actually build a template on site, wherever the template is, or wherever the project is, usually a kitchen or a bathroom, something like that. And what I'll do is actually use wood yardsticks to carefully make a template. I use hot glue to hold it all together. And then I would come and put that on here and build the form around it. But in this case, because I know the base for the desk is exactly square and I know the exact dimensions, I can just draft the shape of the piece nice and square right on my form. Now I use melamine to build forms for the GFRC tops, and whatever I'm building in GFRC, I use melamine. 3/4 inch thick. You can get this at Home Depot or Lowe's. Comes in 4x8 sheets, very heavy, really hard to handle by yourself. But what I typically do is cut it down to a reasonable size for the piece that I'm making. So I've cut this piece at 34 inches and I've left it full length, which is 97 inches in this case. And then I'll show you here in a second, but I've drafted the size of the top for the desk, which is 84 inches by 30 inches. I've drafted that in green. And then what I'll do is I've cut strips of melamine that are 1.25 inches high. And I'll use hot glue to put those in just the right places on top of the sheet of melamine. And that's going to form the basis for our concrete form. I'll do some time lapse for you so you can see exactly what I mean. It does take some practice. There's other ways you can use drywall screws to hold the melamine walls to the sheet below. There's all kinds of different ways to do it, but this is what I found works best for me. So with that said, I will kind of show you how I do the walls with the hot glue, and then I'll tell you about the next step. All right, so we've got the sides of the form built. We've got them in place with the hot glue. The hot glue is actually quite a bit stronger than you would imagine. I use the Gorilla Glue heavy-duty hot glue sticks. I find they work best. You can get them on Amazon or probably Home Depot. The next step is we got to seal the corners of the form. Now, to do that, I use 100% silicone caulk. But before I do this, I'm going to take paste wax on a microfiber cloth and put a film of wax along the sides, all around the corners. Then I'm going to take and put a bead of the silicone, and this is black so I can see it against this white melamine. Put a bead of the silicone in the corner, and then what I'll do is take a ball modeling tool. You can get these online, that are for a variety of things, crafts, I think maybe even cakes and that kind of thing. But once the silicone's in there, I'll quickly, before it starts to skim over, run the ball modeling tool through the bead of silicone, and it'll squeeze out the excess, leave a nice rounded corner there. And then when the silicone cures, because the wax is there, I'll be able to easily pull up the excess. It's pretty cool. You'll see what I mean as we get into it here, but I wanted to be sure you understood what you see me doing here with the silicone and the ball modeling tool. Very important. So the silicone has fully cured. Best to leave it overnight if you can. It really depends on temperature. If it's very warm, you might be able to get away with 6 to 8 hours, but I always like to leave it overnight if I can. So now what we're going to do is finish off these corners by removing the excess silicone that we squeezed out with the ball molding tool. You can see that because of the wax, the excess comes out very easily. In fact, you can usually just pull it out in strips like this. All right, and as you can see, what we're left with is a nice molded piece of silicone in the corner that has a rounded edge because of that round modeling tool. And that's going to leave a nice eased round edge on our desktop. I'm going to go ahead and remove the rest of these excess pieces of silicone. And then what I'm going to do is clean the entire melamine surface with acetone on a microfiber rag. That's going to give kind of the final cleaning before we put cement into the mold. Well, I've got the form ready to go. And the next step in my process is to batch out all of the materials. Now, GFRC is comprised of many ingredients, and I'm going to kind of go through what those are here. You can buy sack material that contains all of these ingredients pre-mixed. It can get kind of expensive, and depending on where you're at, you may have to get that shipped to you, which can be very expensive as well. I'm fortunate I can find all these materials locally here in Denver. And so I typically buy all the materials separately and then batch it together before I mix and put into the mold. Now GFRC contains, of course, cement. Cement is not all created equal. I typically use pure white cement. I can buy that locally here. It's called Lehigh White. And I can get that at Rio Grande here in Denver. Then pozzolan. Pozzolan is also a cementatious material. I use a specific pozzolan called VCAS 160, and it is available here in Denver as well at Reynolds Advanced Materials. Then, of course, we need aggregate, in this case sand, and I use 30 mesh silica. You can usually find graded silica like this at specialty building supply or concrete supplies. Here in Denver, I get that at Rio Grande as well. We need water, of course, very important to hydrate the cement. But also very important for GFRC in particular is an acrylic polymer. And I use a product called Forton VF774. And this is very important because it has chemical properties that allow us to speed up the curing process and prevent a lot of the problems with concrete creation. And so instead of what you typically have to do, like a 7-day wet cure, this allows for more like a 24-hour wet cure. Now, it's pretty cold here in the shop today. It's 45 degrees in here right now. Over this past summer, I was building concrete in here at up to 85 degree shop temperature. And so when it's really warm like that, that accelerates cement. Cold temps slows everything down. And so instead of the 24-hour cure, I'm going to go ahead and let it sit for at least 48 hours, maybe more if I can. I'll also be covering the piece with blankets after I'm done with the pour today. Back to the ingredients list. The other primary ingredient is, of course, the glass fibers. The glass fibers is what we're using for the reinforcement. The glass fibers need to be at least 3% by weight of all of the other materials combined. And so as we're mixing, I'll show you that here in a little bit. The glass fibers go in last, and then you put it into the mold. Now, very important is the first coat of concrete that goes in the mold. I'm actually going to spray it. It's called the face coat. The mold is upside down right now, so the top of the piece is actually going to be right up against the melamine sheet, if you can imagine that. And in order to prevent pinholes and air pockets in the concrete, I'm going to spray that first coat in. And so the face coat is going to be a little different from the rest of the concrete that goes in the mold. As I mentioned, the rest of the concrete is called backer coat, and it has the glass fibers in it for the reinforcement. Face coat, no glass fibers. And you can do different things with a face coat to make it cool, because that's what's going to be seen on the top of your piece. In my case, what I'm going to do is take out the 30 mesh silica sand and replace it with a ground up fine glass silica substitute. And I find it really makes the piece look cool, kind of sparkles in the sunlight. You can imagine the glass in there instead of the sand. And so I'm going to mix that together for just the face coat. Now you might be wondering, how do you know how much of all these ingredients? Well, I have developed a spreadsheet over the years that I've been doing this, and it carefully calculates, based on the size of your piece, how much of each ingredient that you need. And I will weigh out all of these ingredients. That's what I call batching. I'm going to weigh out all these ingredients very carefully. Now to do that, I use 3 different scales. I have a bucket scale that can weigh up to 400 pounds accurately to the ounce. I have a kitchen scale. It's actually right here. This can weigh accurately to the 1/10 of an ounce, up to 10 pounds is what it's rated for. I try not to go over about 6 or 7 pounds on this scale. And then I have another small scale that's gram accurate, and I use it for pigment mostly, or very small weights of materials. Speaking of pigment, that's another ingredient in the GFRC. I typically use all white ingredients and then use pigment to get the color that I desire. I strongly recommend making test pieces to get the pigment just right. Make sure everything is good before you start working on big pieces like this. But today, kind of a unique piece here. For these desktops, I did some testing and I found that an addition of kind of standard gray cement that you might find at the hardware store is honestly the perfect color for what we're looking for. And so based on test panels that I built, I'm going to be using, for just the cement component of the ingredients, 60% gray and 40% white for all of the face coat and backer coats. And I found that it just gives a really neat, kind of a natural cement color that's going to be perfect for our space. Now, like I said, normally I would use all white materials and use pigment to get the color that I want. That's a much more safe, and you can repeat the color very easily that way. Gray cement from the hardware store or wherever you buy it from can be a little bit challenging to work with. Depending on where you're at, it can be different colors. Even maybe different batches could be different colors. And so in my case, I bought 2 sacks of this gray cement from the hardware store from the same pallet. I'm very comfortable that it's the same color. I'm even going to mix the 2 sacks together so that I'm 100% confident that between the 2 sacks I have the exact same color. And of course I'm going to weigh everything very precisely so that I'm comfortable that I have the same color throughout. Again, I don't recommend using gray cement for any of this. I have just found that for this particular project, it's going to work pretty good. With all that said, I'm going to go ahead and batch all this out. Definitely wear a dust mask for this. The cement is, it goes up into the air very easily, and you don't want any of it in your lungs. It is not good for you. Same with the sand. The glass substitute, it comes up in dust. You do not want to breathe any of this in, so please be safe. Wear the dust mask. Well, as you can see here, I've got all the materials batched out. In this row of buckets in the back there, I've got the both white and gray cement, as well as the pozzolan. In these buckets here, I have the sand. And as you can see, I'm going to be mixing in a 5-gallon bucket. Is it ideal? Well, no. I can only do small batches. I'd love to have a stand mixer, which is a much bigger device for mixing very large batches. But again, as a hobbyist, this is kind of what works for me. And so with my spreadsheet, I've been able to determine that I need 3 batches of the backer, which is going to have the alkaline resistant glass fibers. These are 3/4 inch long, resistant to the alkali that's found in cement, so that they, are strong for the long term. And then, of course, 1 batch of the face coat. I'm going to mix the face coat first, and I'm going to be modifying the viscosity of the face coat so that I can put it in this hopper gun. This is called a hopper gun. It uses air to spray concrete mix. Concrete goes in the top part here. And then, of course, you can aim this wherever you want. Makes a little bit of a mess, but not terrible. And this is what I use to spray the face coat into the form. Now, to modify the viscosity, get to use a little bit of chemistry magic here. This is a chemical that temporarily reduces the viscosity of concrete. Often called water reducer, also sometimes called plasticizer. But really cool. You'll see it makes a heck of a difference. A cement or a concrete mix that's pretty stiff, you add some of this and it becomes very less viscous for sure. And it's the only way really that I can be able to spray it in this hopper gun. So for this first batch of face coat, I'm going to be moving quick. With the spraying and the temporary reduction in viscosity, I'm going to be moving pretty fast. So I'm going to probably not talk a lot about the mixing process on this first batch, but on subsequent batches, I'm going to walk you through the mixing process very carefully. I'm going to do some time lapse so you can see the spraying and really the creation of the whole piece. All right, now that I've got the first couple of batches into the mold, I got a little bit more time. I can chat about the mixing process. The order in which you put all the ingredients in and mix it is somewhat important, just to make sure you get everything incorporated properly. You start out with the water. Now I do have a little bit of excess from the previous batch in the bucket here, but I start out with the water. Then this is the polymer, and it goes in with the water. Now at this point, if you had pigment, you would put the pigment in and mix it to make sure it's incorporated into the mixed water. But since we're not using pigment today, the next is the sand. Now, a lot of folks would say you should mix the water with the sand. I find that that step isn't necessary for these these batches of backer. So I go ahead and add about half of the cement. I'm going to go ahead and mix these ingredients, make sure everything is nice and wetted. And now I'll add the remainder of the cement. Now I like to take a margin trowel. I use a margin trowel a lot during any concrete work, and just scrape the edges of the bucket here to make sure that we get all of the dry materials off the edges. So now what I'm going to do, and it's important that you have a shear mixer like this, high speed. You really want to make sure that all these ingredients are incorporated well. Now that it's mixed, I'm going to go ahead and let this do a false set for 5 minutes. I find that it just helps my mix be more consistent while I'm trying to work it into the mold. So 5 minutes, and then I'll come back and adjust the viscosity with the water reducer and add the glass fiber.
All right, our 5-minute false set has elapsed now, and we're ready to give it a mix and then start making additions of water reducer to lower the viscosity. Really, we want to make it to where we can pour it into the mold and have it self-level somewhat. I'm going to work it into the mold with the margin trowel, but we'd like it to have low enough viscosity to be able to move around a little bit and reduce the air pockets as much as possible. So like I said, I'm going to start mixing and reducing the viscosity. Kind of takes some practice. You can add too much water reducer, and when that happens, the aggregate drops out of solution of the concrete mix. Very bad. You don't want to do that. This is a cool tool, but you cannot abuse it. So we'll kind of work through that and get this just right. Okay, as you can see, this is nice and runny. Now I'm going to go ahead and add the fiber. It's the last piece to go in. And now I'll slowly mix to get this incorporated. We may need to add some more water reducer. We'll just kind of see how it acts. It looks pretty good. I'm going to add just a little bit more water reducer, and then we'll be good to put this in the mold. All right, well, I've got all the concrete in the mold now. That's the face coat, and all 3 batches of backer coat are all in the mold now. You probably saw on the time lapse where I was shaking the trailer. I find that when the concrete is in its kind of lower viscosity state with the water reducer, if I can vibrate it a little bit, move the trailer back and forth a little bit, it really helps get the air bubbles out and even the slurry in the mold. That's all finished. It's nice and level. I'm going to go ahead and cover the piece with plastic now. You always want to cover GFRC pieces with plastic after you're done. The reaction of the cement with the water is a chemical reaction. The concrete does not dry out. It cures, and it has to have the water. And so we don't want that water going anywhere. We're going to keep it right in there under plastic. And then because it is quite chilly, it's about 45 degrees in the shop right now, I'm going to cover it with a blanket or two, try and keep the heat of the reaction of the concrete in the piece to help it cure. All right, it's been 72 hours since we did the pour. Plenty of time for the concrete to cure for our next steps here. Even in these cold shop temps, the 72 hours is going to be plenty. So next, I'm going to remove the blanket and the plastic, get the trailer cleaned up here, get all the plastic off. And it's a pretty nice day today, so we're going to pull it outside and do the grinding and honing. All right, so the first step in finishing our concrete piece here is going to be grinding the back. Now, what you see facing up right now is going to be the bottom of the piece. It's upside down right now. And I did my best to screed and level the top with the sides, but it's not perfect. And we want to make sure it's nice and flat and 1.25 inches throughout the whole piece.
So what I'm going to be doing is using a grinding wheel, concrete grinding wheel. Now this is a 5-inch wet polisher machine. I'm going to be using this for both the grinding on the back and honing on the top. But right now this is a 4-inch turbo wheel or a concrete grinding wheel. I'm going to be doing this part dry. Honing must be done wet, but the grinding on the back can be done dry. And basically I'm going to go around the sides and level it perfectly with the melamine form, and then, you know, pass over the entire piece to make sure it's all nice and level. And then I'll take a 4-foot straight edge and take it and move it along the piece, kind of riding the sides of the form, and mark out any parts that are high. I'll do that with a permanent marker. And once I get those marked out, I'll take the grinder, knock those parts down, and I'll keep doing that until I'm comfortable that the whole piece is 1.25 inch thickness. And I can take the straight edge and move it across the whole piece without hitting any high spots. Now this is a very dusty process. I'm doing it dry. Very important to wear a dust mask. Could even use a respirator. Oh, if you were inside, it'd be just miserable. There's a little bit of a breeze here today, so I'm going to be using a dust mask. Eye protection, very important, and then hearing protection. This is a pretty loud machine, so you definitely want to do hearing protection. So I just finished the grinding process, and it really wasn't that bad. It was actually almost perfectly level. Just had a few little places to knock down. And the next step is going to be demolding. Now, you got to be very careful in this step. It's actually easy to damage your piece at this point. It's kind of like Christmas, you know, opening up your mold and finding out what your piece is going to look like. It's a lot of fun, but got to be careful. I'm going to be using a steel demolition lever and a hammer to gently lift up the sides of the mold. And then once I've got all the sides removed, I'm going to carefully lean the piece up and actually roll it over onto a couple of pieces of wood. And so that way the top is up and I'll be able to work on the honing process. Like I said though, gotta be careful on this step. It is easy to damage the piece. Well, as you can probably tell, these pieces are heavy, and probably best to have 2 people if you can to roll them over like that. I mean, this piece weighs more than I do. It's a couple 100 pounds, so got to be careful. Now, I do have it in the position I'd like it for the rest of the finishing process. You know, it's up off the trailer, so I can get around it, under it, supported on wood, nice and stable. And so the next step is actually going to be drilling the holes that we're going to use to mount the screens on top of the desk, and also the cord pass-throughs, so the cords can come down to our cable management tray underneath the desk. I'm going to draft the locations of those holes very carefully. I'm going to use masking tape and a pen to do that. And then I'm going to use an impact drill to drill the holes for the screen mounts. And I'm actually going to use a concrete hole saw for the pass-throughs for the cables. So with that said, I'll go ahead and draft the holes and get the drilling. All right, so I've got all the holes drilled in the top of the piece and ready to move on to the next step, which is honing. Now, honing is basically the process of removing the very fine top layer of the piece to expose the aggregate. In our case, this is going to be that fine glass that we used as a silica substitute. Now, the piece has right now a cream finish, and cream is the cement that settles on the very bottom of the form and kind of hides the aggregate below it. And you'll see a cream finish on sidewalks or really any place you see unfinished concrete. Some people like the cream finish. It does look cool. If you've done a good job of putting the concrete in the mold, you use the spray gun and don't have any air holes or pinholes in the concrete, you could clean this up and seal it and be done. But I have found that the cream finish just is not very durable. It's just a little soft for what I'd like to do with this piece. And so I'm gonna hone the cream off, get down into the aggregate where it's a nice, hard, durable surface, and expose that beautiful glass that we put in there. I'm also gonna hone the sides. To do that, I use a hand polishing pad. You could try to use the machine for polishing the sides, but if you don't have the angles just right, kind of gouges and makes an uneven surface. So hand polishing pad for the sides, and then using the 5-inch wet polisher here with a 400 grit diamond sanding honing pad rigged up on it. This is a wet polisher, so I've got the hose hooked up and we'll have water coming out the center here. That'll keep the pad lubricated, cool, and clean. For the hand polishing, I'll just be using the hose with me to make sure everything's clean and cool. This takes a little bit of practice. It's a big machine and powerful, and you want to make sure that you don't leave any honing marks. And so you'll see that I'll be doing a bunch of kind of small circles, circular motion to keep a nice even cleaning and honing surface. All right, well, as you saw, I've got the initial honing process all finished. The piece has been inside, back in the shop here, and completely dried out. And without a doubt, after you finish the honing process, you're gonna see some pinholes, little air pockets that were in the face coat, and we need to fix those so that our final piece is very dense and we don't have any little spots that are gonna collect any stains or have any problems in the future. So the process that we're going to use to fix these little air pockets is called grouting. And grouting is simply going to be mixing up a peanut butter-like consistency cement blend, and we're going to force that into those little holes and pockets with my fingers. Now, the blend that I'm going to use is the same ratio of cement and pozzolan that we used for the face coat, because we want the color to match. If we had used pigment, we would use the same ratio of pigment as well. So in this cup, I've mixed 60% gray cement and 40% white cement, just like I did for the face coat, and then I've added the same ratio of pozzolan as well. The mixed water that we're going to use for this process is 2 parts of water. I like to use distilled water for this, and then 1 part of the polymer. Now, the polymer is very important. It's going to serve as a bonding agent. That's critical to get cement to bond to cement. You need a bonding agent, and this polymer is going to work great for that. So I'm going to mix this up. It's going to be kind of a peanut butter-like consistency. I'm going to have a spray bottle of water with me. I may miss the surface in places to help get the cement to work into those little holes. It's very important that you cover the entire surface with a grout. You can't just kind of selectively hit little pinholes or air pockets. You've got to do the whole surface. It does slightly change the color,
and you don't want to have little color splotches after you do the next honing process. So make sure you get all the pinholes covered, but you've got to cover the whole surface. And it's good because there's pinholes that you can't see. You want to get everything filled as well as you can. I do like to use my fingers to force the grout into the holes instead of maybe a plastic putty knife or something like that. I find that with my fingers I can do a much better job. So I'm going to do the grouting process, and then I'm going to cover it with plastic again. I'm going to let it sit overnight before we do our next round of honing. All right, well, as you can see here, our grout is plenty cured. I've given it plenty of time to get hard. And it does have an odd appearance. I mean, you know, putting all this cement all over your brand new concrete piece can feel a little odd, but not to worry. Our second honing process is going to easily blow right through the cement layer, the grout layer, and leave all those pinholes nicely filled. So that's what I'm going to do today. I'm going to hone this a second time. Pretty much the same process as the first time. I'm going to hand hone the sides and this eased edge here, or the corner, and then use the 5-inch wet polisher to hone the top. At that point, we're going to have a good look at it, and you know, there's a good chance we would grout it a second time and hone for a third time. We want to make sure all these holes are filled and that the piece is very dense on top. All right, we've got the concrete honed again, and it is ready for sealer. So just to recap, we did the initial honing, we grouted, we honed again, and we grouted a second time and honed it for a third time. And feel comfortable that we have all the pinholes filled. Piece looks great. Got a nice smooth surface right now, and we're going to proceed with the sealing process. Now, the first step in the sealing process, I'm going to actually take a microfiber rag with acetone and wipe the surface off. That'll make sure there's no dust or any residue left over from the honing process. I did rinse it very good. In fact, I scrubbed it with a green scrubby pad and rinsed it over and over again until the rinse water was clean. But just to make sure we don't have anything on there, we're going to do the acetone and then start the sealing process. Now, the sealing process, I use a product called Omega, and I've used it for many years. I'm very comfortable with its performance and how it works. And what I'm going to do is do a priming process first. And I'm going to mix up a batch of its polyurethane sealer and mix it with 7 parts water. So 1 part sealer and 7 parts water. And I'm going to spray that very liberally on the surface and use a scrub pad to work it into the surface. And I'm going to leave it essentially saturated on the surface for maybe 5 minutes. Make sure that it seeps into any porosity. And that's when we're going to get our wet look also. It's a color enhancing sealer. And so after it sits on there for about 5 minutes, then I'll take a roller, a foam roller, and I will make it so that it's a very thin layer of primer remaining. And I'm gonna be careful to avoid roller marks. That's gonna be very important. I've kind of perfected a technique to avoid roller marks. And then we're gonna let that flash off, or essentially dry. It's not gonna be cured, but that initial moisture layer is gonna flash off. And I'm actually gonna do that process twice. So 2 primer coats, and then we'll be ready to do what we call final coats. All right, we just finished our 2 coats of primer, and while it's kind of finishing up drying, I'm going to mix up the
sealer for the final coats. Now the final coats are a little different. I'm going to be doing 1 part sealer to 1 part water, so much less dilution. And I'm going to take a spray bottle, spray the sealer onto the surface as evenly as I can, and then take the foam roller and just I'll kind of work it over the surface first and then back roll it very quickly before it has any chance to dry. Try and get just a thin film of sealer on there and then quickly move to the next section. I'll be working in sections of about 18 inches at a time by the width of the piece, which is 30 inches. And move very quickly with this step before the sealer has any chance to dry, and just keep moving down the piece. I'm going to probably do about 4 or 5 coats to make sure we get a nice thick, a thorough coating of sealer over the entire surface and be very durable for a very long time. Got to be sure and get the sides and the edge here. Got to make sure everything is coated evenly. It is very cool in the shop today, and so I'm cheating a little bit by using a fan between coats to just gently put a breeze over the piece. It is very dry, the air is very dry, so it does flash off quite quickly, but just to help us along here today, I'm using the fan. In a hot shop, you do not need the fan. In fact, it dries so fast, it's basically chasing you as you go. You have to move very, very quickly. I like to let the sealer cure for at least 48 hours before moving it. I then brought the pieces back to my home shop where I was able to fit them to the steel desk bases. I drilled the holes in the desk to exactly match the locations of the holes in the concrete, and then the bottom desk base was ready to go off to powder coat. After about 3 weeks, I was able to retrieve the desks from the powder coat shop. For the color, we chose a 20% gloss black, which is a beautiful satin finish. Looks great in our space. We're super happy with it. First step in installation, of course, was getting the bases inside the office space. Easier said than done. They are quite heavy. Used carts to get them in, and now that they're in the space, I am installing the cable management trays. Next was installation of the keyboard drawer. Super happy with how this turned out. I did spend a lot of time working out exactly how this was going to function. In the end, it all came together exactly as planned. It fits nicely, slides very easily, and is going to be very functional. The adjustable feet went in just as planned and helped me level the desk on the floor. This front outlet is one of my favorite parts of this build. It is going to be very useful, and it looks great as well. After I started building the desk, I decided I wanted to organize the computers a little better, so I built this shelving system that attaches to the side of the desk. I did make it so that it'll attach to either side if I have a different configuration in the future, and this will serve to get the computers up off the floor and help organize them. Next step was installation of the concrete top on top of the steel base. Moving it into the house was a little challenging, but once we got it on top, everything lined up perfectly. I built these screen mounting poles out of 1 3/8" diameter steel tube, 1 1/8" thickness, wall thickness, so it is very strong. I built them by using a 1/4 inch weld nut welded to a small piece of round 3/16 inch plate, and then welded a tube on top of that so that I can attach a bolt from the bottom. These monitor light bars are what I came up with for task lighting for the desk. I've got 3 of them. They all work on the same remote control. You can change the color temperature of the light as well as dim them if needed. They seem to be a great option so far. And that's it. The desk is completely installed. I'm happy with how this all came together. The steel base is beautiful and unique, and the concrete top has modern style and will be very durable. The small details like the screen-mounted LED lighting, the new KVM switch I installed, and the front-mounted outlet all help make this desk more functional. The 7-screen setup works great for my technical stock analysis methods, and I love how neat and organized the computers and cables are. Although this project took me much longer than I had expected, the finished product was well worth the effort and the time. These are lifetime pieces that we'll enjoy using every day, and we'll pass these on to our kids someday. Thanks for watching, and stay tuned for the next project.